Okay. Yeah, do. Okay, so 8.2. Now we're going to be looking at properties of something called chords. So chords it's not really a tough concept. So a chord is just any line that connects one side of a circle to another. So just anywhere on that circle, that's just considered a chord. Okay. So here, I'll let you guys play around with this too, so you can move those things around. So from last lesson, right, we can also mess around with the diameter, right? The diameter of the circle is always going to be from, straight across the longest distance.
So would your diameter be considered a chord?
It is too, yeah. The diameter would be a chord as well. Yeah, but you can have a chord anywhere in this circle. And then the radius as well, you can move that radius around, and that's always going to be half of the circle.
Thick line.
All right.
The diameter, radius, and chord were the same.
Okay, so now the new concept with circle geometry is something called, this is a big word, it's the perpendicular bisector of a chord. Let's see if we can like figure those words out. What does the word perpendicular mean?
The opposite of parallel. Right?
Yeah, with a hand, yeah.
It's not parallel.
It's not parallel? Yeah, it's definitely not parallel, yeah.
So it intersects.
Yeah, so I'm going to draw that. So perpendicular, well, like you guys were saying, it's not parallel. Parallel would be two lines that are, never touch, right? Perpendicular are when you have one line and another line, and they are at 90 degrees to each other, right? So perpendicular, so that's what I mean. So we have a perpendicular. Now, what do you guys think this word would mean? Bisector. It is like you might be able to figure it out. Yeah, so bi means two, right? And if you bisect something, what do you think that means?
Split in half.
There you go. If you to bisect means split it in half, right? So right in the middle. All right, so let's.
Splitting a chord in half.
We're splitting a chord in half.
Cool.
All right.
This is a split in half chord.
I think that really struck a chord with you guys.
Okay.
All right, so if this is my chord, right, this green one, then the perpendicular bisector, I just have it written as bisector here, would just be the line that splits this in half, right? So if you split this thing in half, so this side is the same as this side, then it would create a right angle with that, right?
But it doesn't look like it's a right angle.
It is.
I know, but because the lines like.
So no matter where you put it, this thing will be at a right angle. Now, so perpendicular at 90 degrees, it divides into two equal parts. So now the next little thing that we're going to do is if we relate this also to the radius of this circle, right? So if you play around with this one, look at this. What if I bring this thing down, 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 down until the point where I meet the edge of that chord? What have I now created?
A square.
In a special triangle, it's a right angle triangle.
So you can do the
We can do Pythagorean theorem now.
Pythagorean theorem.
Yep. Yeah, exactly. So here, I'll open this up. You guys can play with that for a second. All right, so question was, if we bring this thing around to the other side, right, down to this side, is this a right angle triangle?
Yes.
And yes, it still is, because if it's 90 degrees on this side, it is also 90 degrees on that side. I just don't have the little symbol there, right? Now, properties of bisectors of perpendicular to chords. So, a little bit of theory here. You guys need to know these three properties. We're going to do three properties for this lesson, and then there's going to be three properties in the next one. So part of it is just like memorizing these different mathematical properties. So the first one is the perpendicular bisector divides the chord into two equal parts. All right, so I think we have that one figured out, right?
Yeah.
That's really just saying that if we have this chord, that it's going to split right in half, right? So the length of this side would be the same as the length of that side. Okay, so that's property one. Property two is the perpendicular bisector to a chord passes through the center of the circle. All that's saying is if you have, it's kind of like the other way around. If we have the perpendicular bisector, so this blue line, it would always pass through the center of the circle. It stops at the center, but like you could also extend it through if you wanted to, right? Property three, the perpendicular bisector forms a 90-degree angle to the chord. So like what I talked about in the last one, right? let's move to the next one. Okay, so that's pretty much it for the notes. Now let's actually just try a few, just based on that concept. So this one says if line AF is equal to 9. So remember how we do this? We go from A to F. So this section is 9. Then FL is, and don't yell out the answer.
Oh.
Yep.
Oh.
Wait, so.
Let's see how we did.
Wow. Oh my
What?
god, you were her choice.
All right.
Who gets the 18?
I got it.
Okay, so looking at this, guys, so looking at this one, guys, it was if AF is equal to 9, so AF is this section from here to here. And then just be careful, FL is from here to here. And if this really is a perpendicular bisector, then they'd be the same length, right? So if it's 9, then it would also still be 9. All right. All right, next one. If MN is equal to 9, then NI is equal to... All right, I'll open this one up. So just read that one carefully. Make sure you know which length you're looking at.
Hold up.
Do-do-do.
We're making fun of it.
All right, pretty good.
I said if you need a
So yeah, whoever had 9, you just be careful that MN, right? MN is the whole one. And then NI would be from here to here, so that would be half, right? So it'd be half of 9. All right, we're getting a little bit more complicated now.
What?
Okay, so looking at this one, you can't move it. I mean, so you can't move it. Determine angle PMZ. So I'm going to let you guys see if you can remember from last lesson what that would be. PMZ, what angle would that be in this thing? So I'll open that up for you. All right. All right. 36 is correct. And how do we get to that? So, well, actually, yeah, before I do that, though, let's make sure we know what this even means. Well, that's not the right one. What this even means. So if it's saying angle PMZ, right? That's saying from P to M to Z, right? So it's actually this angle. It's really, it's going to be the middle. It's going to be the middle letter is what we're after, right? So the concept here was that we just had to know that this was a right angle, right? Because it's a perpendicular bisector, because we know this length is the same as this length. Okay? And then what do all the angles in any triangle add up to? 180, right? So this is just 180 minus 90 minus 54. And you probably could have skipped a step there and just went 90 minus 54. Yeah.
Can we try again? I don't want to redeem myself.
You want to redeem yourself? Okay.
Sometimes it looks like...
All right.
Oh.
Next one here. So it says, oh, that's a 6 there, by the way, if you can't see it. It says really nothing. You just get the picture of the circle, and it says determine line WA.
Oh, yeah.
So I'll open this up. So see what you guys think. Line WA.
Yeah, bro, that's...
Oh, and this 11.4, guys, would be the hypotenuse here. If you haven't, it's not this length. The 11.4 would be this length. Kind of showed up a little strange there. All right, for you guys at home. All right, so in this example, this is a right angle, right? Okay, so that's our first key. Now, if this is a right angle triangle, then what can we do? We can do what theorem? Yeah, Pythagorean theorem, right? But how is that going to help us? Because we were looking for this length from here to here, right? What, like that? Right, that was the first key here, was that I really need to find the length from W to P, because once I find that, that just is the same as A to W, right? So this is just a Pythagorean theorem question. But careful on this one, though, because if you just started typing in 11 squared plus 6 squared is equal to C squared, that's not going to turn out right. Why wouldn't that turn out right if I went 11 squared plus 6 squared is equal to C squared? I already have C, right? The 11.4 is my C. So this becomes a little different. This is going to be C squared minus A squared is equal to B squared, right? I have C. Like, this is my C. This is my A, let's call it. And this is my B.
What?
Does that not make sense?
Wait. Just a second.
Okay, so I'll keep going. So 11.4 squared minus 6 squared is equal to B squared.
Okay, wait, but what was the answer?
Just one. I'll keep going.
19 point something.
Wait, I got 9.6.
Okay, so I'm gonna type this in. What's that?
I get 9.69. That's what I got too.
Yeah.
Wait, how do you know what you see?
Okay, let me go. Maybe I have a mistake here. Let's keep going.
But it wants the full length.
No, it's only double.
It's only W to A. Okay, let me keep going. Okay, so we've got
Yeah, but it wants the full length.
11.4 squared. Okay, 11.4 squared minus 6 squared equals, right? So that's too long, so then we're going to do square root of that. So then square root. So 9 point, yeah, so it looks like my answer is wrong.
Oh.
Oh.
No, I
So
I
whoever
went
got
on
it
to
right
the
just got a
questions.
random number.
Mr. Brown, I went on to the questions, and basically it wanted me to times it by 2 for the full length of the chord.
Yep,
And
so
that's the right answer.
yeah,
for some
so
reason.
that's the problem when I wrote this question, right? Is I made the answer from A to P, right? So that's what that would have been from A to P. So whoever had, let's say, 9.69, that would have been the right one. This 19.36 was double, but yeah, do you guys know what I mean? Like it's
correct?
this. I gotta change this question to say W to P instead of W to, or sorry, A to P, not yeah. Anyway.
May I go get some water?
I'll change that as soon as we're done here. Okay, so next one here, guys.
It did it for question 9.
All right, guys, so next one here. So click point N to interact with the image, so you can interact with this thing. Now, using the information provided, determine the value of IQ. So from I to Q. And this is the information we have. This is 12 miles, and this is 10 miles. So I'm going to leave you guys to this. See if you can figure this one out. It might help to move this to a specific position. Do.
I got it wrong.
How am I wrong?
All right.
I told you did something
It was
wrong.
from, so whoever had, like the people who had 6.63, these ones.
That's what I got.
Anybody see what was wrong with that one?
It sounds like
Wait, did
Times it by 2 because this is from I to Q.
Right, Tucker.
From I to Q. So if you found like, so very first step you want to do here, right, is the reason why I made this thing movable is so that I can actually move this down right to here.
I did it to the other way.
Or the other way, yep, wouldn't actually matter. So from there to there, right?
Okay.
So now Pythagorean theorem, right? Now we can say, all right, so if we're there, this is like my C, and this could be my A, and that's my B. So now we'll say C squared minus A squared is equal to B squared.
Isn't it A squared plus B squared?
It would normally be, but this is the hypotenuse, right? We're starting with the hypotenuse. So we got to go C squared minus A squared is equal to B squared. So careful on that one. That's commonplace to make a mistake. So this will be 12 squared minus 10 squared is equal to B squared. So 144 minus 100 is equal to B squared. So this would be 44 is equal to B squared. So is my answer 44? No? I got square root, right? So square root. And I got a feeling, just based on your guys' numbers,
Like 6 points.
that it would be, yeah, it would be this number. So that's good. So a lot of you guys got that one right. But then, so 6.6. So
Oh, so precise.
that would be this, right? This would be like 6.6.
Oh, I've been getting it wrong the entire time.
That times it by
Okay, well, now you know. That's good. So that's 6.6, but just we know that this really is a perpendicular bisector. We have to multiply that by 2 because we want to go from N to A, right? The
No,
whole
we
thing.
wanna go from I to Q. No, that's half of it.
Oh, sorry, it was the...
Yeah.
It's because I moved this thing in front of it.
What even is I? Oh, wait. Oh, N's covering.
N was on top of it, though.
Oh,
Yeah.
it is the full length.
Yeah,
Never mind.
it's
I
the
was
full
just
length there,
saying
yeah.
multiplied by the end.
All right, so people online, we're trying this one now. Again, you can interact with this length, and that might be helpful.
I think I'm smart.
Oh!
Got it. All right, so people watching at home, let's go through this. So step number 1 was to be able to picture this radius as actually being the hypotenuse of that triangle, right? So sometimes you won't be able to move this. So I made it so you guys can move it so you can see that relationship, but sometimes you won't be able to. And you'll just need to kind of like either use your drawing tool that some of you guys have on your computer to draw it in, or just kind of picture it as being, the hypotenuse right there. So either way, I'm going to move this over here for now. All right. So I made myself a little right angle triangle. So now, if I do that, then, well, what I want to do first is I want to figure out what the length of this side is here. I'm going to call this A.
Yeah.
Okay?
Oh.
And I'm going to call this side B. Well, you know, actually, I can call it B. Or
Yeah.
what is the length of this side from here to here?
15 feet.
It's definitely 15, right? Perpendicular bisector. This side is the same as the other. So that's 15 as well. So now let's figure out A. So A would be, so it would be C squared plus B squared?
Minus.
Yeah, minus B squared. So minus 15.
Minus.
Here, I'll do B squared.
Oh, I think that's what I was doing.
Is equal to, you were adding, yeah, common mistake. Okay, so then C squared, so that's a 17.1 squared, minus 15 squared is equal to A squared. All right, and then from here, I'm just really going to put it into my calculator. So let's bring the calculator out. So it would be, so 17.1 squared minus 15 squared. And then don't forget to push equals to actually see what those are equal to. And then the very last step there, I would square root it, right? So 8.2104.
Then you subtract that number off of 17.
Well, why then?
I'll show you in a second here. So 8.2104 is equal to A, right? So that's what this is. And I'll round it for a second. This is like, let's call it 8.2 from there to there. So how does that help us? Watch this. This is going to blow your guys' mind.
Because that's the same length as the whole thing.
Watch this.
So X should be 8.2 as well.
Well, no, it's not necessarily half. Even though it kind of looks like the distance from there to there are the same, they're off by a little bit. They're not always going to be the same, right? Because you could make this chord could be lower or higher, right? It wouldn't have to be the same there at all.
Oh, that's how you get it.
So now, look at this. So if this is my radius of my circle, what if I extend this thing all the way down to the bottom?
Subtract 8.2 off 17.
Right? Can you see that this length here really is the whole length down to the bottom? The whole thing is 17.1. So if the whole thing here is 17.1 and this length is 8.2, my last step would just be to go 17.1 minus 8.2 would be X.
I feel extremely smart right now.
Most redemption.
Does that, are you guys are getting a little quiet, I'm hoping. Does that mean it doesn't make sense? So then that ends up being 8.889, yeah, 8.89. Let's do it again, yeah.
Yes, I want to speed run this. Don't speed run it. Jordy, you don't
Oh, yeah,
All right, if you're watching at home, look at all that green.
Except for that one red that's just
What a month.
red
That
sauce.
one that's sus. No, it's nice.
All right, great question. So, using what you just learned, right? Now we have to kind of picture it. If you have that drawing tool on your computer,
Yes.
that might be a good thing to pull out. Because, so this example says the arc, okay, so listening. The arch in the diagram below forms a complete half circle. The black support beam in the diagram is 3.2 meters in length and is 2.7 meters above the surface of the water, right? So this is half, like this is a half of a circle, right? So the center of the circle would be like right here. Okay, so they didn't fill in all the lines that we just had, right? So it might be up to you to kind of draw the lines where you think they might go. So now it says to the nearest tenth of a meter, the diameter of the arch is. So the diameter, the length from here to here, the whole thing. So I'll give you a little hint on this. If you wanted the diameter of the arch, what would you probably have to find?
The hypotenuse.
Yeah, which would be the radius, right? Yeah, so we're really after the radius in this case. So here, I'll let you guys try.
Oh, you times it by 2. Yeah, I didn't
I times it by 2, but it
Oh, we didn't times it by
I
2.
did.
I didn't times it by 2.
I times my answer by 2.
Oh, I forgot to times it by 2.
Okay, so let's go through this one. So if you're watching from home, key to this one was making your triangle the right way. So if you're doing it on paper, I'd sketch this out, kind of make a little this little diagram. Or if you have your extension on your computer that you can draw on your screen, then use that. But either way, this is going to be the key, right? So let's look at what we're even after. So in this case, right, we're after the diameter of this thing, the distance all the way to the end, right? So what I want to do then, I'd really like to just figure out what the radius is, because what's the diameter? It's just the radius times 2, right? So I need the radius. Is any part, can you guys see any part of this triangle that I've drawn is any part of that triangle the radius of the
Yes.
circle?
The up and actually the up and no the to the corner.
To the corner, yeah. Yeah, the hypotenuse, right, of that triangle, that is the radius. Right? Can you see if I like pulled this down here, that actually just would be the radius of that arch? From there to there?
And then you multiply by 2.
Yeah, so really I'm after the hypotenuse of this guy. And then once I figure out my hypotenuse, I just need to multiply it by 2. So let's do that. So we're after R. What do we know here now? So it says that the black support beam in the diagram is 3.2 meters in length, right? So that's the whole thing here. It's 3.2 from there to there. Okay, so that's going to be the key. Yeah, so then, and the, what is it, 2.7 above the surface. So this is 2.7.
And 1.6.
Right. So I'd sure like to just figure out the distance from here to here, right? So that would be, like you said, 1.6.
4.73.
So now we're good. So this is a squared plus b squared is equal to c squared. And this time, I really do want c, right? I want the radius. So it'd be c squared is equal to a squared plus b squared. So c squared is equal to, and then we'll call a 2.7 squared
I got 4.
plus 1.6 squared. So c squared is equal to, and we'll put that in our calculator. So that would be, I'll clear that, 2.7 squared plus 1.6 squared equals 9.85, and then I'll take the square root of that. So that's 3.1384.
Why did I get 2 point something?
3.13, let's call it 8. Okay, and that was C, sorry, I already took the square root. So now, it looks like a lot of people had that as my answer, right? 3.13, yeah, by a few of those. So then, what's the last thing I gotta do? Times by 2, right? Because that was the radius. The diameter is 2 times that.
So we forgot to
Just,
times by 2.
yeah, just forgot times by 2. That's an easy one. That's a, yeah,
Simple mistake.
simple mistake. That doesn't mean you don't know. I just probably forgot what you were looking for. Okay, you guys want to do that one again?
Sure.
No.
Maybe not. Let's like you said. Let's
We
move
start
on.
working.
How do we do the
I can't really remember. I think
We do like
we are done that actually.
One